Let us talk about the arithmetic of the probability. We need to perform mathematical operations on probability when we are dealing with more than one events at a time. For the sake of clarity and brevity of computation, we will define certain types of events. So let's understand what is a mutually exclusive event. So mutually exclusive events are the events that do not have any overlapping outcomes. It implies that one event occurs, the other cannot occur. These events complement each other, but the same event occurrence of a experiment cannot be part of two events at the same time. For example, when you roll a dice, if you are seeing an odd number on the face of the dice, you cannot see an even number. So getting an even number and an odd number are mutually exclusive events. Similarly, let's understand what's an exhaustive event. A completely exhaustive event are the set of events that completely encompass the entire sample space and include all possible outcomes of an experiment. The events that span over the entire sample space are completely exhaustive. There is no outcome or an occurrence possible beyond what is already enumerated or occurred in the completely exhaustive events. Let us say when we roll a dice, there are 6 possible events. 1, 2, 3, 4, 5, 6. These are the 6 occurrences. When we combine these 6 occurrences together, it encompasses the entire sample space. So these 6 events with these occurrences 1, 2, 3, 4, 5, 6 are completely exhaustive. Similarly, we talk about the intersection of events, which represents the AND condition of occurrences. So what does it really constitute? It constitutes of overlapping set of occurrences in 2 or more events. These occurrences meet the criteria of 1 or more events simultaneously. Say 3 on the face of the dice can occur as a part of event wherein we speak about the numbers divisible by 3. It can also occur as the part of the event when we are looking at the odd outcomes in the rolled dice. So 3 is the one which occurs in both the events, which meets the criteria for both the events. Such events which have the co-occurrence or which has the occurrence of a certain outcome which is part of both the events represent the intersecting events. On the other hand, we have the union of events which represents the OR condition of occurrences. This means that occurrences that either fulfill the conditions of event A or event B or both. For example, 1, 3, 5, 6 outcomes in rolling a dice. Either it fulfills either divisibility by 3 because 3 and 6 are the only 2 possible outcomes, or an odd number which is 1, 3 and 5. So divisible by 3 and odd number together represent the union of the events. Now with this we will work out the mathematics or the calculations involved in combining the outcomes of the multiple events. So let's start with the addition. So when the events are mutually exclusive, a simple addition of the probability of event A and event B gives us the probability of event A or event B. Whereas in case of mutually non-exclusive events, probability of getting either A or B will include probability of A and probability of B, of course, but when the events are non-exclusive, an occurrence which is common for both A and B will get doubly counted in the probability of event A and probability of event B. So it will be counted in both of them. So we remove the commonly occurring event in both of this, commonly occurring outcome in both of this event, so that the double counting is eliminated. So we subtract the common outcomes. Similarly, let's talk about the multiplication of the events. So when the events are independent of each other, in that case, a simple multiplication of the two probabilities gives us the probability of A and B occurring together. In case of dependent events, wherein B depends on A without losing the generality, the probability of A and B is equal to probability of A times the probability of B given A has already occurred. So this helps us combine events and arrive at the combined probability of multiple events together. Now, calculation of any probability involves counting of the occurrences. Sometimes the counting is straightforward, sometimes it is complex and difficult. For that, we take the help of the constructs of permutations and combinations from the combinatorial world. Let me define what is permutation and what is combination. Permutation is the selection of items in which order matters. If we are performing an experiment in which the order in which the items are getting selected is important, we can use the formula of permutation to count the number of such selections. So given n items, if we are selecting r items at a time where the order is important, the number of permutations of the selections is given by n factorial divided by n minus r factorial. On the other hand, combination is the selection of items in which the order does not matter. Number of combination of n things taken r at a time is given by NCR, which is n factorial divided by n minus r factorial divided by r factorial. What we essentially mean here is r factorial are the possible arrangements of the order in a permutation. So we eliminate those permutations in combination to arrive at a number wherein we have no concern for the order in which the items are selected.